Hey, 8th grade, welcome back. Welcome back to the second installment of Learning Math with Mr. Bauman from Mr. Bauman's Basement. So here we are, back again. Glad you're able to join us. I hope these YouTube videos are working out, and I hope each of these YouTube videos finds you and your family all doing well and making the best of the hand that we were dealt, so to speak. And I know you guys are making the best of it. Doing the best job you can with the work that we're asking you to complete, and we really appreciate that. And I really miss you guys. I certainly wish we were back in school, seeing your smiling faces every day, but this is the hand that we're dealt, and we're going to make the best of it. I know you guys can do it. So welcome back to my basement. I decided to change the location, just to change the location. So here I am, right next to my pool table. Got a corner pocket right here. Lots of these are record albums that we have hung in some of the walls of our basement. But welcome back. And today we are going to spend a little bit of time reviewing. I'm going to use my whiteboard again, so just bear with me. And can't start any math lesson. That's right, without a good old sip of the black coffee. Still good, still cold, but still good. So, we are going to review today graphing. If you need to go grab your notebook, go ahead and do so. We're going to be graphing lines using Slope-Intercept form. As I mentioned in, I think it was the last video, maybe it was the Zoom call that I had earlier with some of you. My hope is that we are going to spend these e-learning days reviewing really the core or the fundamental, the most important standards from 8th grade. Because in all honesty, before we left, we had just finished. In fact, your last YouTube video was the end of scientific notation, and that was the official last core standard from 8th grade. So I'm going to use these e-learning days, these YouTube videos, to really kind of firm up or kind of make more solid your understanding of the essential or the fundamental standards from 8th grade. So this is definitely one of them, graphing lines using slope-intercept form. I'm going to zoom in here a bit. I feel like this is too far away. That's crooked. And you can't see me. Excuse me a second. Mr. Bauman obviously has not found his razor yet, so sorry you got to stare at that. But there we go, that's better. Alright, graphing lines using slope-intercept form. So here's what we're going to do today. We're going to review some of the basics of slope-intercept form. You might be asking, well, why? Why are we looking at slope-intercept form again? I'm not going to lie to you. Haven't lied to you yet. But you, next year when you get to high school, slope-intercept form is huge, like really big. It's really what the hokey pokey talks about. Slope-intercept form is what it's all about. And so I want to make sure that this is as firm, as solid, as strong as we can make it, your understanding of slope-intercept form, so that when you walk into that first day of high school, you're feeling just really comfortable and confident with your abilities to graph a line if your instructor gives you the line in slope-intercept form. And today, we're actually going to look to see what would happen if it wasn't in slope-intercept form. How can we make it? How can we convert it into slope-intercept form? So just a quick review, because I know it's been a couple weeks since you guys have seen this. Slope-intercept form. By the way, if you need to pause the video, go grab your notebook or a notebook and just kind of earmark it as your math notes, so that when we do get back to school, you can just insert those into your math notebook. Slope-intercept form, really two main components. We have the slope, and then we have the y-intercept. Slope-intercept form will always and forever look like that. Y is equal to mx plus b. So let's identify the different parts. We know from 7th grade that m represents the slope. That's right. And b, there's a couple different names we gave to b this year. B we can call the y-intercept, which I just mentioned. And if it's a story problem, anything that's measuring something from real life, we can call it, in many ways it could be considered kind of like the starting point. So this is the y-intercept or the starting point. Obviously then m, again, is the slope. That's kind of the bare bones of slope-intercept form. So let's jump right into an example. And again, if you have graph paper, I don't, but if you have graph paper, you might want to take out a sheet. If you don't have graph paper, you can certainly make your own. I'm going to ask you to do a little bit of graphing on your assignment for today. If you have graph paper, great. If you don't, just freehand the coordinate plane, but try to use a straight edge if you have it, just so your lines are as precise as you can get them. And for the homework, you can either just take a picture and email me the graphs, or you can insert that picture. I believe you can insert the picture into the actual Google Doc. So it's just all one document for me to look at, which will include images of your graph. So whatever is most convenient for you, I'll figure it out, you figure it out, and we'll just make the best of what we're dealing with here, and know that, in the words of Troy Bolton, we are all in this together. Let me move this camera here. There we go. All right, so let's jump right into this. I want to try to graph y is equal to 4/5 x minus 2. Y is equal to 4/5 x minus 2. So just like that, you should be able to tell me what's the slope. That's right, it's 4/5. What's the y-intercept? You betcha it's -2. Remember, whatever symbol is in front of a number goes with that number. So even before you put pencil to paper, you should already in your mind have this kind of mental picture. Gunther is going up. I think I'm looking at the camera backwards, but I'm pretty sure that's up to you guys, because the slope is positive. Since the slope is positive 4/5, the line is going to be rising from left to right. It crosses the y-axis at -2. So this one, because it's already in slope-intercept form, really doesn't require a ton of work on our part. If you have graph paper, now would be a good time to use it. If you don't have graph paper, just freehand the coordinate plane. Do the best job you can. Step 1, graph the y-intercept first. Graph the y-intercept first. That is some terrible handwriting that I have there. I apologize. Graph the y-intercept first. So we know that the y-intercept is -2. I go down here on my coordinate plane, and I plotted -2. In many ways, that's considered the starting point. We said Gunther is going to be rising. At what rate is Gunther rising? He's rising at 4 units for every 5 units that he runs. So he's going to go up 4 and then right 5. Like the sound effects? Up 4, right 5. Which means he has to be going up. So he's going to rise 4, 1, 2, 3, 4, and then run 5. So I've got a second point of 5,2. From here, not from the origin, but from the y-intercept, rise 4, and then run 5. And that's all you need. All you need is 2 points to determine one distinct line. 2 points gives one distinct line. So at this point, if you have a straight edge, I don't right here, but I'll do the best job I can. You're going to draw a straight line through those 2 points, and then name it. This is the line y is equal to 4/5 x minus 2. Pretty basic I didn't really tell you step 2. I told you step 2, but I didn't write it down. Use the slope to graph a second point. Use the slope to graph a second point. And there's our line. Easy enough. But what if, that's kind of the basics there. Let's take it one step further. Throw you a little bit of a different pitch here. That's what you just saw was kind of a fastball. Let's look at a slider here. For those of you with baseball or softball backgrounds, let's look at a little bit of a slider. What if I gave you something that looked like the directions would be the same. I want you to graph y minus 2 equals negative 6x. Y minus 2 is equal to negative 6x. It's a little bit, it looks a little bit different because it's not in slope-intercept form. But we can put it, we can convert it into slope-intercept form. Slope-intercept form has y by itself. This y is not by itself yet, but we can make it by itself by using inverse operations on this guy, this negative 2. How can we undo the negative 2? That uses some of the knowledge we learned from 7th grade. We have to undo it using inverse operations. The inverse of minus 2 is plus 2. But the whole teeter-totter effect, we have to make sure we do it to both sides. These guys cancel. Draw a big line. So we end up with slope-intercept form. Always put the x term first, the variable term first. So negative 6x, and then the constant last, plus 2. How come I cannot combine this term with this term? You betcha. They're not like terms. This one has an x, this one doesn't. They cannot be combined. We learned that in 7th grade. So there's our slope-intercept form. Is Gunther rising or falling? It's falling, that's right, because the slope is negative. Where's Gunther start? He starts at positive 2. That's the y-intercept. So I'm going to go ahead and draw a quick coordinate plane here. If you could do the same, pause the video if you need to. If you have graph paper, you can use the same coordinate plane. Alright, so we plot the y-intercept first. That's positive 2. Looks like that. We said Gunther is going to be going down from, let's see, trying to do this for you guys. That's, I believe that's up. I don't know. You know which way down is. He's going to be going down because the slope is negative. Starts at 2, and he's dropping. Now, here's the tricky part. The slope is negative 6, so we know Gunther is falling. But at what rate is he falling? And I'm reading this backwards. I think that says, yeah, that says negative 6. This is negative 6 over what? This is really negative 6 over 1. Any integer, any number, can be put over 1. So we now know if slope is rise over run, that's what we learned in 7th grade. Slope is rise over run. So because the numerator is negative, it's falling. Since the denominator is positive, he's going to the right. So from here, not from the origin, but from the starting point, from the y-intercept, drop 6 and then go right 1. So I believe that puts us at the point 1, negative 4. From here, drop 6, go right 1. How many times could you do that? How many times could you drop 6, go right 1, drop 6, go right 1, drop 6, go right 1, forever? Or, if you're feeling really crazy, I could have gone up 6 and then left 1. Still puts me on the same line. there's literally infinitely many lines, or excuse me, infinitely many points that you could include on this one kind of straight line. I just happen to do 2, because honestly that's about all the room I have. Down 6, right 1, or up 6, left 1. Alright, if at any point you have questions, shoot me an email. Shoot me an email, and I'd be happy to do my best to clarify. I'm going to try to do Zoom calls towards the end of each week. It's kind of an office hours for you to chat live if you wanted to on anything that you may have had questions with. But once you get done with this video, I'm going to ask for you to complete maybe 4 or 5 questions on Google Classroom. Again, if you have questions when you get there, please email me or jump on the Zoom later this week, probably on Thursday, which for me today is Tuesday. This video I don't think is going to go out to you guys until Wednesday, so this assignment won't be due until Thursday. So shoot me an email or Zoom. All right, let's take this one step further. So what if you're trying to graph the line, but the y-intercept is not given? So if they ask you to graph, or if I ask you to graph on this assignment, graph the line if the slope is, let's go -3, and the line passes through the point -1, 2. Graph the line if the slope is -3 and it passes through the point -1, 2. And I'm going to add kind of a secondary question to that. What would the equation of this line be? So not only graph it, but what if I asked you to take it one step further? What would the equation be? I'll give you a chance to write that down. So, probably going to need a coordinate plane. Not probably, you are going to need a coordinate plane. Let's graph this. But we don't know a whole lot. We know that Gunther is definitely falling, so the line's going to be going down from left to right. But we don't know what the y-intercept is. Let's see if we can find it. Alright, let me draw my coordinate plane here real fast. So only thing I can really plot right now is the point that I gave you, which was -1, 2. Let's go and plot that first. So from the origin, go left 1, up 2. So far that's really all I know about my line, except for the fact that I know it's going to be falling. I know it's going to be going down from left to right. At what rate is it going to be falling? That's right, the slope we know is -3, which is really -3 over 1. So I'm going to go down 3, right 1. So from the point that I know, go down 3, right 1, and oh my stars, it happens to cross the y-axis. I went down 3, right 1, and it crossed the y-axis. Do I need any more points? No, I've got 2. That's really all I need. And one of them happens to be the y-intercept. So there's part A to my question, what's the graph look like, or what's the line look like? That's what the line's going to look like. And now if I wanted this in slope-intercept form, I already know the slope. That's -3. And I now know the y-intercept is right here. The y-intercept is -1, That's my value of b. So the equation in slope-intercept form, y is equal to negative 3x minus 1. Let me show you a little shortcut. What if the question didn't ask you to graph? What if the question just asked for this equation? Is there a faster way to do that? And the answer is yes. This is a little bit of what you're going to get into next year in high school, but you guys are ready for this. I'm very confident in that. So same question, let's avoid doing a graph. Doesn't that sound nice? Avoid doing a graph. I love graphing, not going to lie to you. I love it a lot, actually, but I'm kind of a nerd. Not kind of, I am. But I'm okay with that. Let's try to do this without graphing. So I want it in slope-intercept form. Let's plug in what we know. There's 4 letters here. There's 4 variables. I know 3 of them. If there's 4 variables and you know 3, you can use the 3 that you do know in order to figure out that one that you don't know. So of these 4, which one do I not know? Let's pretend we don't know the answer yet. I don't know this one. I don't know what B is. I know a Y, I know the M, and I know an X. Let's plug those in. So I know that the Y was 2. I know the slope was negative 3, and the corresponding X was negative 1. So I plug in what I know to figure out what I don't know. Let's solve this very basic, straightforward 7th grade equation. 2 negatives multiplied together gives a positive 3. Now undo this positive 3. Totally 7th grade math here. And oh my stars, we get negative 1 for the y-intercept. So we can plug that back in. And we got the same answer that we got like 2 minutes ago. Much faster without a graph. Alright, so that was more like a, gosh, probably like a change up. If we're going like baseball, softball analogies here, let me show you one final problem. I promise, this is the last one. Last problem, I'd consider this like a curveball. I mean, honestly, this is one that I want to try to do with a graph to start off, and then I'm going to try to show you a shortcut again to try to solve this without using the graph. Okay, so we're going to do this twice. The first time we're going to use a graph. Second time we're not going to use a graph, and we'll see which way takes us a little bit less time. Again, this would be considered the old curveball. Okay, so what if I asked for the equation of a line. I'm trying to write fast so you guys don't fall asleep. That passes through the points -2, -1, and 2, 3. Alright, if you need to pause the video so you can get this down, what's the equation of a line that passes through the points -2, -1, and 2, 3? You'll be doing one like this on your assignment today. Go ahead and pause the video if you need to, because I'm going to move on. Let's do it with a graph first. Let's just plot these 2 points. See where they see what happens. There's -2, -1. Probably should label my points here. -2, -1. Now let's plot the other point, 2, 3. And keep in mind I didn't use graph paper. Some of you may be using graph paper, some of you may not. But your line should look about like that. Without doing any other work, I know that my slope has to be positive, because old Gunther his flowing locks of hair, he's going up the mountain. And since he's going up the mountain, we know that our slope has to be positive. You could kind of take like the 7th grade approach here. You could count blocks because they're all integers. It'd be fairly straightforward to do the blocks. So it looks like we rise, or Gunther rises 1, 2, 3, 4. Rises 4, and then he runs 1, 2, 3. Also runs 4. So I got a slope of 4 over 4, which we all know reduces to 1. 1 over 1, or just 1. So if that's the slope, and do I know the y-intercept? Yeah, I think I do, even though I didn't use graph paper. It looks like it crosses right here. It looks like it crosses the y-axis at 1. So the best I can tell without graph paper, my equation in slope-intercept form would be 1x plus 1. The slope is 1, the y-intercept was 1. Now, that's one way to do it. Not terribly time consuming, but let's see if we can do it in a little bit less time with some straight up algebra. Gotta love it. Algebra is your friend. So is my coffee. Alright. Let's go back to your other good friend, slope-intercept form. Again, there's 4 variables. Y, M, X, and B. 4 variables. As long as you know 3 of them, you can figure out the 4th. As long as you know these 3, you can figure out the 4th. We already calculated the slope, but we could go kind of old school 8th grade algebra here, and we can use the formula for slope. You guys want to do that? Yeah, let's do that. That's kind of exciting. So if we name these guys x sub 1, y sub 1, x sub 2, y sub 2. So I name my points. Let's plug it into the formula. I'm going to pause the video. You calculate yours. I'll calculate mine. Let's see if we get the same answer. What should we get? Should get 1. Let's try it. Alright, the big reveal. Whoosh. I got 3 minus negative 1. 2 negatives together become a positive, so that's positive 4. Same deal down here. Subtracting a negative, that's the same thing as adding a positive. 2 plus 2, easiest question of the day. That's 4. 4 over 4, we know, is 1. So, oh my gosh, we got the slope. Now, let's plug that in here, and let's plug in either one of the y's and its corresponding x. We're trying to avoid graphing here. Let's plug, I'm going to use this one, only because it doesn't have any negatives. So let's plug in 3 for y, 2 for x, and we now know the slope is 1. Let's try that. 3 for y, 1 for x, or excuse me, 1 for slope, 2 for x. Alright, do a little basic 7th grade pre-algebra here. 2 times 1 is 2. Undo the 2, and oh my stars, we got the same y-intercept. Math is amazing. Algebra is amazing. So are you. We get the same answer that we got like 2 minutes ago. Y is equal to 1x plus 1. Very similar to what I'm going to ask you guys to do tonight, or today. Your call. If you want to use the shortcut, use the shortcut. If you want to graph it on graph paper or your own coordinate plane, by all means, go ahead and graph it. But I think that's all I have for today. If you do have questions, again, shoot me an email, and you guys are going to rock and roll through this assignment. So I think I'm going to ask for maybe 4 or 5 questions, you basically utilizing what we just did here today. So if there's no other questions that I have for you, which I don't, I hope you guys are at least somewhat enjoying these YouTube videos. I hope you find them beneficial. Again, moving forward after spring break, I'm going to hit really the kind of the key, most crucial, most important standards from 8th grade. Review those skills with you so you guys are ready to rock and roll when you hit high school this fall. So with that, I won't see you guys again until after spring break. So I wish you a very enjoyable, fun-filled, safe, and healthy spring break. You got some extended time to kind of relax, unwind, sleep in, stay up late, watching movies, whatever, and enjoy some good family time. We don't get that very often, and so I hope you enjoy your time with your families. And if you do have questions, make sure you email me. But with that, I won't see you guys for about a week or so. So have a great spring break. Be kind to one another. Be kind to your family. Be patient with your family. We're all trying our very best. So please be kind and be patient. But above all, as I've been saying, please pray. I think it's the most perfect form of peace, and I think that's what all of us need right now is just as much peace in our life as we can get. So please continue to pray. Pray for each other. Pray for your families. Pray for me. I need it. And know that you guys, all of you guys, are in my daily prayers. I pray for your safety and your well-being for you and your family every day. And so I wish you nothing but the best over spring break. And until I see you guys on the next installment of Learning Math with Mr. Bauman from Mr. Bauman's Basement, this is Mr. Bauman signing off. Have a great spring break.